Thank you, Mamoon. Appreciate the presentation. Our second presentation is going to be done by Houjun Tang. Houjun is a PhD level computer scientist who's been instrumental in all of our data development for the EQSIM framework. And we have turned his talents now towards analyzing data. And he's going to give an overview of the EQSIM agent that's under development.
Hi, everyone. Thanks, Dave, for the introduction. I'm Houjun Tang, a computer scientist at Berkeley Lab. Today, I will be talking about our work, EQSIM Agent, a conversational AI for interactive exploitation of large-scale earthquake simulation data. So over the years, or in the accessing the large-scale earthquake simulation data, there have been several stages or several different solutions. At the very beginning, we have the current SGMD has the flat file, which are Excel or text files, and they are useful because they provide a standard format for people to access the simulation data as well as other real data sets. But the main issue with this is they are just data files, and if you need to do anything, you are required to do manually filtering and lookup and static offline analysis, and you basically have to do a lot of things by your own, create your own workflows. And then we have new capabilities added on top of these flat files with the SGMD, the web-based search, and also the EQSIM width that Mamoon just went through. And this provides a number of capabilities such as parameter search, where you can specify the latitude, longitude range, or some PGA, PGD values to look for the size that may be interested of you. And they also provide a map-based plots where you can look up a specific size, whether those ground motions that might be interested for your need. But those plots display are predetermined. So we are always showing the about 2,270 size for one map, and each map has shows the velocity, acceleration, and displacement plots. And so along this direction, we are thinking, how can we make this more interactive? And with the new age of the AI, how can we utilize the AI technologies to help making our data more accessible to the users and helping the user to locate their data more straightforward and without a lot of manual work. And that's why we have explored a work called EQSIM Agent. And for this agent, basically it intercepts natural language requests, and it can also support interactive selection on the map. Besides the static generated size, we integrated capabilities so that the agent can support a dynamic multi-step workflows with the help of AI. And it also can support follow-up questions so that while you are doing exploration, you may not initially know what you want to, what data you want to get. So you may ask a series of questions and limiting your selection gradually. So we have that in mind. And also we provide a bunch of deterministic tools for scientific correctness, because large language models, they are probabilistic models, and also they don't know about our data. So we have to have tools to access our data for them to use. Overall, the main task we are targeting for the SGMD users is something like find a subset of ground motions relevant to my site to a particular fault, or answer an engineering question. And our goal for this EQSIM agent work is to move from where is the data to show me the size, motions, and spectra that may answer this question. So now we go through kind of the workflow of how the EQSIM agent works. So basically, the very high level is you ask a question in natural language, and the EQSIM agent will generate an answer that will generate a response that answers your question. So for example, a user may ask, find out the size with a PGA greater than 0.8 G within 5 kilometers of the Hayward fault in realization 4. And we send this request have the large language model to interpret the intent and what are the actual filtering conditions like the PGA and the fault distance, and then it will convert those into a set of EQSIM tool calls. And for that, we will have the EQSIM agent runtime to execute those tool calls that access and queries the data based on the user requirements, and then compute the results. And finally, we will send those results back to the large language model for synthesizing or summarizing a final response. So one important thing I want to mention is in this entire process, we are not relying on the LLM to directly generate an answer, because they do not, they may have some general knowledge of what SGMD is, because there's a paper and they are probably trained on that paper, but they definitely do not have access to our actual ground motion data. So we are not relying on to generate an answer with their internal knowledge, but rather we are asking the large language model to propose actions based on the user question, and to generate what EQSIM tools should be called to answer this question. And when we feed the tool results back to the LLM, it will summarize the final answer and present the results back. So going a bit deeper of how everything works internally, just to give you some brief understanding of how we interact with large language models, is that we are not just sending the actual user question to the large language model, but the runtime we are assembling a package of all the things that the agent is capable of for the large, so to give the right context for the LLM to decide what to do. So in this package, we have the 4 main components. First one is system prompt, which gives a general idea of the general context, so the LLM understands that it should be dealing with the SGMD data and not just other regular requests. And then we are sending the tool descriptions and their schema. And currently we have about 24 tools, and the total description is almost 7,000 words. And these tools may include some specialized capabilities. For example, we have a tool to get the realization names for a specific fault that the system has access to. And then also there are another tool is finding the locations with certain conditions. And we also, besides the system prompt and tools, we also send the previous questions so that the LLM has an understanding of the previous test. So user can ask follow-up questions without typing all the previous context again. And this will all send to the large language model, and it will return a tool call. For example, for this request, it will say that we need to call this tool and with this condition, and then the agent runtime receives this tool and executes, validates the parameters first, make sure the large language model is not inventing new parameters, and then it will execute the tool and generate the response. And then it will, for example, for this one, it will, if it finds 47 matching sets, it will send back to the LLM and for it to summarize in its final answer. And during this process, we are actually using the tools to access the actual data. And as I mentioned before, we are not asking the large language model to generate answers based on its knowledge. So now for the another overview of the system, how things work is in the background, we have the EQSIM agent runtime. It can be run on the NERSC spin system, which is can run this as a container. And we have the agent runtime that does various operations. And then we have a web app that provides a chat and map interface, which is shown on the left. And I will go have a demo next to show you more details about this interface. But on the back end, the EQSIM agent runtime, it will connect to an external large language model API, and also has a connection to the actual data. So we have hundreds of terabytes of simulation data stored at NERSC, and that the agent has access to during runtime. So next, I will switch to a live demo, and hopefully things work out, because with the large language models, you may not always get the right answer you expect. But anyway, here is the basic front page interface. So just at a glance, it may just look at another chatbot, but as I go with more details and show more capabilities, I'm hoping to show you that this is more than just a chatbot that can just answers your questions, but it's a more interactive tool for exploring the EQSIM SGMD datasets. So for first question, I will just show a quick example. So if the user is not familiar with the SGMD dataset, they may ask a question, just list the simulation realizations that the agent currently have access to for the Haber plot. And so you type in this request and you click the send button. So a new window will pop up. On the top right-hand side, it will show the question you just asked. So this interface is pretty much similar to all the chatbot like ChatGPT interface, and the agent runtime in the background will access the catalog of our simulations, and it will retrieve those and have the LLM to summarize it into a final answer. So here, if you are familiar with the database, we are listing all R1 to R25 and then the patch versions. And here you will also see some of the newer ones that will be added to the database pretty soon. So there are 10 additional realizations that has some higher velocity. And I mentioned earlier that you can ask a follow-up question. So for example, here we list realizations, and if the user wants to ask additional questions, they can type here. Here I'm just copy pasting, so I don't do the type live. So what if the user wants to know for a specific realization what's the magnitude and the fault mechanism? You can just type in and send a question, and it will go through the agent runtime, and we will. So this question will actually check the flat file with all the simulation information, and here you see the answer is for this simulation, magnitude is 7, and the fault mechanism is a strike sleep. Next, I will show some more examples. So here, a slightly more complicated question is here, if you want to search for a certain sites or stations close to a latitude or longitude, and you want to check their metadata, for example, their latitude, longitude, VS30, and their RGB fault distance, and show them in a markdown table. You can submit this, and in the background, the agent will retrieve the data and then display this markdown table as you requested. So here we see all the 5 stations with their latitude, longitude, and the VS30 RGB attributes listed in the table. And another follow-up is that if you are more interested in specific realization, then you can type in additional questions. So here I'm just maybe if you want to see their motion plots for a specific realization like R22, and you want to show them on a map. So this is one of the features we added to the EQSIM agent that's built on top of the EQSIM width. So here, as you can see, it should show, but let me show you an earlier example where this actually works. So this is sometimes the large language model will return unexpected results. So this is how we are trying to deal with the language model. So there are some uncertainty, but most of the time it should work. So for example, this is an early example that I created before, and this is the actual correct results. So you see it's the same question, show their motions, and here on the right-hand side, you see the map panel, and these markers you can click, and they will show the similar to the EQSIM with marker plots. And actually, these plots are actually reusing the EQSIM plots because we don't want to generate them on the fly. Then I will have some more examples. So Another thing I want to add is that besides describing the selections on them as words, we also add an additional capability where you can draw on a map and draw a selection. So for example, here we have this spatial selection map feature where you can specify a plot. So here I've just specified behavior and pick a realization and click open map. And on the right-hand side, a map will open and we will show the gray dots are the 2 kilometer spacing station markers, and you can zoom in and out. And if you don't want to see them, you can just uncheck them. And on this map, we provide a few selection options. You can do a polygon selection, rectangle selection, and a circle, and also a point selection. So here, let me just draw a polygon on the map, and I will show you how this feature will work. So you see, I just selected a random polygon and on the map, and you can mention that this selection in the text and ask it to show the acceleration plots that are corresponding to the stations within this polygon. So here, I'm just asking it to show the acceleration plots on the map within this polygon, and the agent will generate a new map with showing all the markers within this polygon. And this is also similar to the EQSIM width. You can click and it will show. And for this one, I specifically ask it to display the acceleration plots. So you have the acceleration for parallel, for normal, and vertical. And what's more about this capability is you can actually drag this selection to a new location if you are interested. So for example, here, I'm dragging this to from the Oakland area to San Francisco area, and you can ask again, instead of acceleration plots, now you can ask to show the velocity plots on the map with the new polygon, and you just hit enter. And wait a moment, it will now display all the markers of your new selection. And I added some new capabilities recently to make this more flexible. So instead of, if you want to be more precise, instead of dragging this selection on the map, you can actually ask it to move this selection towards the east for 50 kilometers. It should move around here and show again the acceleration plots on the map. So if you send this request, you will see you get this selection moved to the east and to this area, and still, as I ask it for to show acceleration, it will show the acceleration plots again. But really, you can change this to any other variables, and it should still work. And one more feature I want to show is many people may they may want to move the selection maybe along the plot, so that is also supported. So you can actually send a new request, move the polygon selection along the south, along the plot to the south. Here I'm just saying for 10 kilometers and show the displacements. So you can send this request, and as you see, it is moved from this, but it does not just move from north to south, but it's more southeast along the plot. So this is just one more convenience that we added to this to the agent. And next, I will show some more. Due to the time, I will not show the live, but pre-generated things, just to show you what other capabilities that the agent has. So let me see, plotting. Yeah, so plotting, if you don't like the EQSIM with style static plots, you can actually generate interactive plots. So here, this is a previously generated request I did earlier. So if you have a certain station in mind and you want to compare the motions across different data sets, you can just send this request and it will generate an interactive plot. This is basically, if you know Python or plotly-plot, this is a plotly-plot where you can zoom in and out, and you can select in to show individual time series. And if you want more paper quality plots, we have another option. So this one you can actually do a more like the comparing different sites and from different realizations and put them in a multi-grid plot, where here we see, and you can also specify the time dimension. So not just from 0 to 90 seconds of the total simulation, but here you can specify from 5 seconds to 50 seconds, and we'll show this. And some additional ones, maybe I will show the here. In Mahmoud's earlier example, he showed we can a velocity animation, and you can display this on the map, and also you can ask a follow-up question if you don't want to see the velocity animation. We also provide a PTA overlay, and if you ask that, and it will display this. Finally, I want to show one more example before we go to the discussion, is that here we have a somewhat more complicated example. Assuming if we want to compare our SGMD motions with ASCE design spectrum, and here we see, for example, if you want to read this entire request, we are asking to get a ASCE design spectrum at this specific location, and then we create a 6 by 4 kilometer rectangle selection, and among those, the sites within that selection, and among a few of our realizations, we want to find the top 10 most similar route D100 spectra compared with the SE design spectrum, and the agent will go and access the data generated route D100 and compare them with the ASCE design spectrum. And in the end, we ask it to show them in a comparison plot. So this is the comparison plot we generated, and you can toggle the XY to be linear and log, and see these top results. So now I'll go back to conclude my presentation, and some important notes is that as you have seen, the large language models, they are non-deterministic prediction models. They can generate confident but factually incorrect results. So we did our best to avoid that, but it still may happen from time to time. And in EQSIM Agent, we provide the tools for the large language models to use based on the user's request, and those tools are deterministic, and they are validated. So the overall takeaway is, for large language models, they are useful for translating natural language questions, selecting the tools that we have, and summarize the tool results. But something to watch for is in this, when you are asking a question, you should provide as much information as possible. So to avoid any ambiguity, because if you send ambiguous results, the large language model, they may invent some new things that you may not expect it. And for our EQSIM agent, we have tools that are responsible for reading the data sets and spatial filtering and comparisons, and producing maps, plots, and data downloads. And as I mentioned, the large language model can hallucinate parameters. So although we did try to build everything to safeguard them, but it still may happen. So you should always double check the results. And the guardrails is we have the validated two arguments, actual data and not model memory. And we also currently the large language model, they are not good at long horizon tasks. So we are currently mostly limited to tasks that can be completed within 10 steps or within 5 minutes. And that concludes my presentation. Sorry if I went a bit over time, but I guess we can have some more time for people to ask questions.
Great. Thank